Welcome to Trigonometric Problems Practice session number 3. We have already done 10 problems and now we are on to the 11th problem. Here we have to prove this expression, this complicated term on the left hand side. We have to prove that it is equal to cot squared x, which is the term on the right hand side. Now, if you look at the terms on the left hand side, we have cos pi plus x. Let us look at them one by one. Now, if you use the unit circle concept, which is very useful to figure out the expressions for these kinds of terms, and you assume that there is an angle x which is acute angle, then we know that pi plus x would fall in the third quadrant, and therefore the cos of that would be negative, because cos of that is the projection on the x-axis, which is on the negative side. Now, this relationship that cos pi plus x equals minus cos x is also valid for any value of x, not just acute values of x. Assuming x as acute was only useful to arrive at this expression. And in the similar way, we can figure out that cos of minus x would be equal to cos of x. For example, if we assume that x is acute, we know that cos of minus x would lie in the fourth quadrant, and cos is positive there. And this expression again is valid for any value of x, not just acute values. And then we have an expression like sine of pi minus x, and we can figure out that this is equal to sine of x, and cos of pi by 2 plus x would be equal to minus of sine x. This we have already done previously. Let us now use these expressions to write the left hand side here. So left hand side, that is LHS, is equal to cos of pi plus x, and we already know that it is equal to minus cos of x. Now we are trying to write all of these expressions in terms of angle x, because that is what we have on the right side, cot squared x, and we hope that eventually we will manipulate these terms to get the right hand side expression. So we have minus cos x times cos minus x, which is cos x, so let's write that here, divided by sine of pi minus x, which is sine x, multiplied by cos of pi by 2 plus x, which is minus sine of x. And therefore from here we directly obtain cot squared x, because the negative sign is cancelled and cos x by sine x is cot x, and therefore we have two such expressions which when multiplied give us cot squared x, which is same as the right hand side. So that was pretty easy. Let us now move on to the 12th question. Okay, so we have